So we start with a new problem. The problem statement is based on the lowest common ancestor of a binary search tree, which is actually LeetCode problem 235. So the problem statement is given like this. So given a binary search tree BST, two nodes P and Q, right? For this we need to return the lowest common ancestor, that is LCA. Now what is the definition of the LCA? So LCA is defined by the lowest node in the BST that has both P and Q as the descendants, where a node to be a descendant of itself. So if you see here, there is an example we have given, right? So this is an example. So 6 is the root node, its descendant is 2 and 8, and with the 2 its descendant is 0 and 4, and for the 4 the descendant is 3 and 5. Now in this example we have to find the lowest common ancestor out of that. Now there is a condition irrespective of the problem statement. Now the problem statement is that if P and Q are both less than the current row. So what is the current node for us? So the current node is my root, correct? Then LCA must be in the left subtree. Fine. So similarly, in the condition number 2, if both P and Q are greater than the current node, that is current node is here again root node, then the LCA must lie in the right subtree. Fine. And if 1 and 2 is not the case, then the third case will be the current node, that is the root node, is where both path P and Q diverge. So in this case the LCA is the root itself. Root means the current node itself. So in these three conditions, if you see, right, the condition 3 is valid for in our case, where P is given is 2 and Q is 8. So for this example, if we find the LC is the 6, because is the lowest common ancestor, correct? So that's why I have written here, because 6 is the lowest node that has both 2 and 8 as a descendant. So irrespective of that, so we calculate, and for this we have actually reviewed the concept, right? For any BST property, right, the left child value must be less than the root node value, and the right child value is always greater than the root node value. Now irrespective of this problem statement, the time complexity we have calculated as O to the n, because it is a binary search tree, and the place complexity is O to the log n in this case. Now we go for the coding here. So if we see the coding, so first of all we define a class for tree node, for which we define a constructor where we pass the value having the left child given the value none and the right child given as the none value. Now with the definition of the lowest common ancestor, we pass the root and the PQ value as well. Now irrespective of the condition what I have shown, right, if P value is less than the root value and Q value is less than the root value, then the value is aligned where? In the left subtree, correct? So that's why it is in the left side. So similarly, if the P value is greater than the root value and Q value is also greater than the root value, then it lies where? In the right side. So that is the second condition, LCA must be in the right subtree. Otherwise what happened? Current node is the where path to P and Q as diverge. So in this case, else will print the root itself, which is actually the lowest common ancestor. Now we execute the similar example what I have shown here, 628, 0479 and 35. So after execution, if we see, so we define the or deploy the tree nodes as 6 to 8 as a root left and the right, then 0 and 4 as the left of left and left of right defined for 4. So similarly we define for 3 and 5 in the right hand side irrespective of the left and right. So similarly in the right node we define that 7 and 9, which is actually deployed in root right and to the left, and for the 9 value we actually define for the root right and in the right. Now irrespective of the condition right, we define the condition for the P and Q value, which is actually P is on the left side and Q is on the right side. Now with the function defined for the lower common ancestor right, which is actually defined here, we pass the value or the argument and print the LCA. So it's already computed, so the lowest common ancestor value is the 6 in this case. So this is the example which I have shown. Hope the video is very useful for everyone. Thank you very much.